Okay, we're now looking at training module 4. This is to do with water flow through a control valve. So the situation here, we've got water at a constant feed, pressure of 4 bar gauge flows through a DN400 pipe fitted with equal percentage globe valve. There's a restriction in the form of an orifice, and beyond this there's a sink pressure of 2 bar gauge elevated 6 meters above the source. So we're going to start off by constructing this. I'm going to start a new project here. Create a new Sigma pipe project, and I'm going to create the source and the sink. So the source here, we've got water, and the pressure here is 4 bar gauge. I'm going to call this 4 bar gauge water, and create a new fluid source, and then we need to create a fluid sink here. Here we can look at the question. This is a sink of 2 bar gauge, so 2 bar gauge sink. I'm going to create that one. Now we can add our pipe. To do this, we click the new pipeline and we use the pipe builder. So we're going to use standard connection size. This is DN200 schedule 40, and we want to use our source 4 bar gauge water, and we'll leave that at the default. DN400 schedule 40. There we go. So I'm going to add the source here, and now we can create the flow as we want. So we're going to have a pipe length, that's 1 meter, leave everything default. We also need an orifice here. It's an orifice with an internal diameter of 200 millimeters, and we want to change this to stainless here. And then what else have we got? We've got an equal percentage globe valve, so we can add this in here. A valve, we want to choose the globe valve, and we can adjust the valve curve here. I'm going to leave that default for now, but you can modify that to suit your valve. And we need a pipe bend as well, because it's got to turn to go up. So we're going to use a standard 90-degree bend with a radius to diameter of 2 meters. So that's all good. 2, sorry. Except that one. And I'm going to change this to stainless here. So we'll start off, we'll have a meter length of pipe, and then we're going to have our globe valve to control it, another meter of pipe, and then our orifice, and then another meter of pipe, and we'll turn up. Add the other meter of pipe, turn north, that's the same direction we were heading, another meter of pipe, and then we can add our sink. So that's what it looks like for now. We can now change these to make them suit the question. For example, this one here is 6 meters above the source, and we've got our globe valve, we've got our orifice. So we're looking for the maximum water flow through the system when the valve is 100% open. There's an easy way to modify valves. You can scroll with the wheel while your mouse is over it. So you can see at the top right, I'm modifying that, it moves in and out. So I scroll all the way to 100% open. We can now solve the system. It calculates for us, and it gets 1,124 tons per hour. The next question, will the valve provide reasonable flow control? To look at the response of the valve, we can check out the valve curve here. So we want to calculate the characteristic, how it works with our system. So I'm going to do 10 steps across the range. You can do more, it just makes it a bit more accurate, I guess. But 10 should be fine for our purposes. So this is going to go through each of those situations and calculate the characteristic. So you can see here, it looks pretty decent. This is the installed characteristics here. And we can see as we modify the valve stem position, it suitably modifies the maximum flow. So it does, in answer to that question, provide reasonable flow control. And the third question, if the globe valve were to be replaced by a butterfly valve, would flow control be reasonable? We can edit that here. If we right click, edit, and edit valve type, we can change it from the globe valve to the butterfly valve. We can see the different characteristics here. We'll leave that as the default. You can modify it to suit your specific butterfly valve. And repeating the same procedure, we can have a look at this valve curve. Again, I'll go 10 steps across the range. It does it every 10%, and this is solving at each of those positions. We can see now that the installed characteristics, it doesn't give us very good modification of the flow rate when we're above sort of 50% of our valve capability. So no, it doesn't provide very good flow control. Now we can see what our system looks like. Of course, you can modify this to suit your system as you want.